What's up, geometry scholars, and happy Tuesday. It's also Taco Tuesday, and you're excited about today's class. I'm excited. We're going to continue working on these proofs, and we're going to jump into a little delta math. I'm going to elaborate on that in a moment. First, let's review from yesterday. Here's what I'll recall. I know that if we're looking to prove that angle ACB is congruent to EDF, I know that we're talking about this angle right here and this angle. I recognize that we're going to look for always what? The parallel lines. And so I'm going to sketch it right here. And then we're going to look for that transversal as we have running from A to E. Oh, that looks familiar. And then here is what I know. If we're talking about this yellow angle and this yellow angle right here on the outside, these are alternate exterior angles. And those angles are congruent. Amazing. Let's keep it moving. There's one thing I did want to chat about, and that was from this particular problem right here. A number of students had some challenges with this as a result of it being, a few weeks since we talked about this key idea right here, supplements of congruent angles being congruent. So let's talk about it right now, super quickly. So here is what I recognize. It says that if angle A is congruent to angle J, and our objective is to prove that this little angle is congruent to this angle, that blue B is congruent to blue I. How are we going to go about doing that? Well, I know that red is congruent to red. I recognize that it says angles A and B are linear pairs, right? And so here we have a linear pair on the left side. We also have a linear pair on the right side, and that makes sense. And what do we know about linear pairs? Angle red plus angle blue equals 180 degrees. Angle I plus angle J also equals 180 degrees. And the rationale is that linear pairs are supplementary. That makes sense. And then, so what can we say? We can conclude that blue is congruent to blue because why? Because the blue supplements of the red congruent angles are congruent. Supplements of congruent angles are congruent. We're going to be applying that today. We're going to be applying that throughout the course of the year. You're going to continue working on these proofs. Maybe you're already done. Maybe you've got a lot of work to do. You're going to let me know if you have any questions. I'm going to circulate with about 5 minutes to go, and I'm going to check your work. Let's take a look at this delta math assignment. For delta math, you're going to have a number of problems assessing your understanding of coordinate geometry. It says, draw a line representing the rise and a line representing the run of this line. State the slope of the line in the simplest terms. All right, so what is the slope of this blue line? Well, that's a great question. Well, I know that this, of course, is the y-intercept. And I know that at this point, it also touches the grid, right? And so I'm simply going to count down. So it's going to be down 1 and then 2 to the right. And so we're always thinking about rise over run. So if it's going to be down 1, it's going to be -1 over +2. That is the slope. That, of course, is the answer. Now, I've got a question for you guys. What would the slope be for if we were going to make a perpendicular line to this blue line? And how do you know? We're going to think about, you're going to raise your hand and I see 3 people know. How do we figure out what the perpendicular slope is? Yes, that's right. It is. That is, in fact, actually, let me write it like this. The perpendicular slope is, of course, +2 over 1, or simply 2. And what would that look like? Well, if we're going to start at -3 on the y-axis, we can simply count up 2, right? 1, 2, and then over 1. And then up 2 over 1, up 2 over 1. And our perpendicular line is going to look a little something like this. We'll recall very quickly that perpendicular lines have negative reciprocal slopes. Let's take a look at another question. It says, write the equation of the line that passes through these 2 points, and we're going to put our answer in a fully simplified, and this is critical, point slope form, unless it's a vertical or horizontal line. And I can tell from just looking at these 2 points that it's not going to be a vertical or horizontal line. All right, so here's what I would recommend that you do. The first thing that I'm going to recommend that you guys do is you're going to label the x coordinates, you're going to label the y coordinates, And we've got x1, y1. We've got x2, y2. Beautiful. And so we're going to need to figure out the slope. And here's how I like to figure out the slope. I simply set up the equation like this, and I recognize that it's going to be -4 minus -9, and then it's going to be 3 minus -8. And so what does that mean? It's going to simplify to -4 plus 9 over 3 plus 8, and that gives us what? 5 over 11. So that's our slope. It's going to be up 5 to the right 11. Whoa. All right, so now what we're going to need to do is write this in point slope form. And I'll recall that point slope form is y minus y1 equals the slope m times x minus x1. And you guys are going to definitely have to remember that. And so now let's plug in the values. And so I'm going to actually simply rewrite the equation like so. And we can actually pump in either this red coordinate or this blue coordinate. And so dealer's choice, you know, we'll pop this one in right here. And so here's what I know. We're going to pop in the y value. And in this case, it's going to be a -9. And then we're going to pop in the -8 x value over here. And so when it's simplified, what is delta math going to ask you to write? Y minus a negative is going to be +9 equals the slope. And we'll recall that the slope is, let's check this out. Oh, there it is. It's way up here. 5/11 times x, and then x minus -8 is going to be simply +8. This, ladies and gentlemen, is your answer, and this is what you're going to pop into delta math.